Welcome to everyone who's joined us. Yeah, let's begin. So we have Nirmal with us today. Nirmal has been a valued asset of Wavenet for over 11 years now. He brings extensive experience to his current role as a solutions consultant, and he's all about delivering innovative, effective solutions that help drive our success and support our clients' needs. One of his passions is exploring architecture patterns, and today he'll be diving into this topic on our 7th episode of this TechTonic session. Over to you, Nirmal.
Okay, thank you, Karin. So thank you for joining today's session. So today we are going to discuss about architecture patterns. So first of all, we will check why we need this kind of architecture patterns for software platforms. And first of all, we need to know what is architecture patterns. And second, we will check why we need this kind of things. Okay. So same as some physical constructions or that kind of things, software also we need some proper structured framework to design and building our systems. Why we need this kind of things? Because we need to achieve some areas, not only the technical things, some cost and time, those areas also we need to think before we building a system. So that's why we need to develop a proper architecture pattern before we building a system. So let's see what are the main areas we need to think about. First thing is reliability. Any system we need to build with a proper reliability. And the second thing is performance. Every system we need to prepare with high performance, otherwise your end customer getting dissatisfied and they are moving to a different platform and different services. So we need to ensure the performance of the system. And third one is maintainability. Maintainability means any system if you want to upgrade quickly, or it is a business requirement or any security concerns or whatever the things you have to update very quickly, then your system is ready to welcome those changes very quickly. So that's why we need to ensure that maintainability in your architecture. Another thing is scalability. This is the very popular topic in these days. We need to build our system with scalability, because any system start with low workloads, low user engagement, but with user demand and high workloads, we need to scale the system. So we need to think about scalability also. Another thing is reusability. As a software company, if you have reusable modules and reusable services in your system, in your architecture, you can reuse for other project and other platforms. Then it's a very good benefit for any kind of software company. Another thing is we need to build any system with cost efficient. So those are some main areas we need to think about before we building a system. Okay, so we'll go to discuss today. In today's session, I selected some few widely used architecture patterns. So first one is monolithic architecture pattern. Monolithic means very old and traditional architecture patterns we have. So it's a kind of this kind of architecture. Monolithic means all the modules and all the components in a single code base. That means it's a kind of a single unit. Then any kind of in this example you can see this. Let's assume this is a kind of a e-commerce platform. Then authentication, inventory, category, the order, those all the components are in a single code base and single unit. So even this is a traditional and old architecture pattern, there are some set of advantage also there. What are the advantages in this kind of architecture? It's very simple and it's very good for a very small kind of deployments. So there are no complex integrations and no complex modules and those things. So it's you can simple deployments you can use. Still you can use this kind of monolithic architecture. Another thing is this kind of architecture is very performance is high because this is a single unit. It's run as a one process. So we call this one, because of this one process, this module to module communication going through the same memory space. Then there are no network involvement. Then we can get better throughput from this kind of architecture. So any kind of performance related workloads, we can still use a monolithic architecture design. And what are the disadvantages of this kind of architecture? First thing is scalability. So if you touch any point, that means in this example, one particular module getting high traffic, that means category search, authentication kind of things getting more traffic, and payments with low traffic. But now we want to scale this system, but with this static single unit, we can't scale this kind of platform. So if you want to scale this one, we have to scale whole system. We can't separate it out one module and scale. So it's a inefficient approach. So it's a challenge for this kind of architecture. Another thing is maintains complexity. As I mentioned in the previous slide, maintainability is one of the main point we need to consider, because if we have some changes to the system, it's a technical or business related new upgrade into the system, then it's quite difficult, because if you want to change it, you have to touch complete code base, and then after that, if you change it, you have to run a complete QA cycle, because you already touched the code base, then all are in one place, then you have to run complete QA cycle, and it's take time and cost. So that's another disadvantage of this kind of architecture. Okay, let's go to the next architecture pattern. This one is layered architecture. Layered architecture has some similar pattern with previous one, but here there is some improvements. Improvements means each layer responsible to manage some set of logics. Example, in presentation layer means user interaction and use GUI kind of things handled by presentation layer, and business logic is a separate layer, persistent layer communicating with the disk and databases. That kind of different responsibilities divided into separate layers. So this is a sample example, but we call this one is n-tier architecture also. N-tier means you can increase multiple layers based on your business requirement. So now you can see the benefit of this kind of architecture. Scalability is high, because if you want to scale the business logic layer or any other layer, you can simply scale this layer separately, and other layers remain same. And reusability, if you want to reuse one of these layer for another project or another platform, you can simply take that layer and use it for another project or platform. And easy for testing. Testing means in the maintainability is easy. If we do some changes to one layer, business logic layer or something, then we can run our QA round for that particular layer without touching other layers. So there are some advantages are there compared with the previous architecture. And disadvantages means you can see in this layer has some integration through layer by layer, and most of the time this layer communication going over the network. So if a network come to the picture, if we don't have a proper network infrastructure, there will be a latency that is there, but it's not a disadvantage, it's kind of a challenge. If you have good network architecture and network infrastructure, it's not a problem. Another thing is implementation complexity is there, because we need to properly integrate each layer to layer. Otherwise, it's getting fail or any failures happen. And other thing is, if you not properly architect this kind of, if you use the layered architecture and not properly do it, you have to, if you use too many layers, then kind of over engineering kind of things, if you do, then it's unnecessary complexity and unnecessary performance drop you can experience. So those are some advantages, but you can overcome those things doing some proper designing. And next architecture pattern is service-oriented architecture. Service-oriented architecture means application as a collection of service. That means we can, in the previous slide, it's some technical layers you can see as like a front end, back end, persistent layer kind of things. But in service-oriented architecture, each layer represent and responsible for that some particular service. Example, identity authentication purpose, authentication handling, you can use one layer, and catalog management, you can use one layer. So then that flexibility is there to manage. This is same as previous one, but a little bit advanced, because each layer handle one business logic, completely one business logic. Then this architecture is better than previous one. And flexibility means if you want to add some another service, let's assume you need to integrate some customer loyalty program to the system. Then you can separately develop in the separate team or separate platform or any other external platform or whatever the platform you can integrate into this kind of architecture. And then you have to do only integrations. Then and other layers, other services you can keep as it is. Okay, then that flexibility is there. And you can I think scalability is anyway there. It's a kind of layered architecture. Each layer, each service layer, you can independently scale. And we can reuse the existing service for other product or other projects. So that also there. And disadvantage of this kind of architecture is complexity. You can see a little bit complicated because each layer is independently handled, and we need to integrate layer by layer through some ESB layer and some shared database layer. We need to properly integrate. So in this kind of service-oriented architecture, anyway, those communication, all the communication going over the network. So again, network latency and those performance issue we need to think about. And other thing is a new challenge we have because these all the communication of this service-oriented architecture going through mainly API based. So we need to governance challenges also there. So we need to implement proper security practices if you use this kind of architecture, security authentications and throttling and those things we need to integrate into the. We need to think about when if we use this kind of architecture. Okay. Then we'll move to next architecture. It's a microkernel architecture. This is a little bit different than what we discuss currently. This is mainly this kind of architecture used in our operating system. And some application development also use this kind of architecture, kind of embedded system kind of applications. We use this kind of architecture, but not the enterprise level platform, not use this kind of architecture. Mainly, this is a very simple architecture. There is a core system is there. We can call kernel. This core system manage some kind of functions like input outputs and memory processing management, network management kind of things manage. And we can build some plugins and integrate into the core system. And we can use it. This is the basically we are using in our operating systems. Operating system kernel is there in the middle, and we can build some application as a plugins, then integrate into core kernel. Then this kind why we use this kind of architecture in the operating system, it's fault isolation is there because every plugins and every users in the system separately managed by the core system. That means kernel manage different user spaces and all the processors, all the running process isolated with each other. There are no independently running. Then fault isolation is there. That's why our operating is running properly. One application not affect to the other one, and flexibility is there because you can any plugins component you can integrate into the core system. And some disadvantages means those are some challenges because these communications going through kernel to these components are not very popular protocols. Then you have to good communication and extra complex communication channels you have to use. Then additional, so I think those are some challenges for developers to learn more about these kind of channels and communication path to integrate this kind of kernel modules. Otherwise, we can, that is different challenges actually, not disadvantages. Okay, so there are no point to discuss scalability kind of things. So you can know what is the application of this kind of microkernel architecture. Okay, now we know some few architecture patterns. Then I will move to some architecture pattern classifications. Okay, we discuss about monolithic, and under monolithic, layered architecture, this microkernel architecture, service-oriented architecture, those are there. Under monolithic characteristics are there in these architecture patterns. And the second one is distributed architecture. These days more distributed architecture, and we'll see what are the distributed architecture patterns. Here I need to tell you this service-oriented architecture has both monolithic and distributed characteristics. So we normally, most of the articles and documents, it's categorized under monolithic distributed architecture. If you can recall the service-oriented architecture, in the middle layer, we can distribute. We can distribute, and some areas, ESB layer, shared database kind of things, you can still use monolithic way. That's why it's categorized monolithic distributed architecture. And what are the pure distributed architectures are EDA. EDA means event-driven architectures, and microservice architectures, and these days very popular serverless architectures. Okay, what is event-driven architecture? Event-driven architecture is a kind of a architecture with decoupled components. There is a event producer, and other side the event consumer is there. Event producer initiate and trigger some events. Events means a kind of a state change. If example, let's assume in your website some customer click some button or something, then it will be an event, and or any database change, file change, or whatever the events we can categorize under events. Okay, then there are event producer applications are there, and other side event consumers are there. In this architecture, is the main key characteristic is these architectures loosely coupled, because event producer don't know who is my consumer, and consumer don't know who is my producer. Then these kind of architecture you can easily scale and easily upgrade, because there are no dependency with each parties. Okay. Then this loosely coupling and fault tolerance also there, because it's isolation and scalability. Anyway, we can scale each side without any issue. And this in the middle, there is a even ingestion layer. In this layer, manage some because it's events are flowing this side to other side. There are some additional tasks doing, kind of maintain consistency and maintain queue management, and some other advanced tools are there to we can implement to enrich the events and transform the events. That kind of things we can do in the middle layer. And what are disadvantages in this kind of architecture is very complicated. And then we have some testing challenges. If you face some bug or any other abnormality of the system, then it's difficult to test and troubleshoot. Then we have to, if you are designing this kind of architecture, we need to properly login mechanism and those things. We need to comprehensive testing strategies we have to use if you are using this kind of architecture. And again, latency is there, because most of these communication going not only the internal network, going over the internet also. Then we need to manage that latency also. Most of the time, this kind of event-driven architecture use asynchronous communication. Then that it's the most suitable place we can use this kind of architecture. But that's then we can properly pick this kind of architecture for that if you have latency, then you need to do some things. That means you need to properly design those architecture. And if you have any other, I will give some example. Let's say you are running kind of a Uber kind of application. In that kind of application, use this kind of event-driven architecture, because that kind of architecture, if some events come to one side to other sides, if it delay, it doesn't matter. It's after that next event, it's go to the consumer. Then that kind of application is more suitable for using this kind of architecture. Okay, then microservice architecture. Microservice architecture is a kind of a same as service-oriented architecture. Service-oriented architecture is also some application as a collection of small independent services. Here also microservice also the same, but there are some improvement is there. If you can recall this service-oriented architecture, there are some shared database used, but here in microservice architecture, it has its own database layer. It has its own service logic, as well as their database also inside in the microservice, inside or external. But each microservice has its own database. If you want to maintain some persistent data, then and only you can call to some external common database layer. Otherwise, all the task-related transactional things you can manage that microservice itself. Okay, then this kind of architecture has more scalability and flexibility. Means in this kind of microservice architecture, you can use different technology stack. That means different technologies, the different frameworks you can use. In service 1, you can use Java. Service B, you can use any other Node, or service C, you can use any other different language or different platforms. And database also same. Based on your requirement, different database also you can use. Finally, you can build a platform integrating all A, B, and C. Those are the basic idea of microservice architecture. then most of the scalability, flexibility, fast development, and fault isolation kind of most of the things we can achieve with this kind of architecture. Okay, and other thing is microservice architectures are mainly running on containerized environment. And those advantage also there. We can simply implement some deployment cycles, and we can use some container orchestration capabilities to avoid some fault and redundancy issues we can overcome through that infra level capabilities. And other thing is there are only few disadvantages of this kind of architecture. One is again network overhead is there because it's microservice architecture also running fully through the network. So then we need to ensure the proper network infrastructure. Another one is complexity because these microservices are very small independent services. Then we need to manage each and every microservices. Otherwise, it will be a very complicated things because most of the time those microservices are running on containerized environment. Then we need to manage those things. So you have to use some kind of a additional platform like a Kubernetes and Docker kind of external application, external infra level platform you can use to avoid those complexity. And other thing is you can use some kind of a microservice deployment and manage software to reduce your complexity. So that's why those are challenges, not actually blockers. Okay. Then next architecture pattern is serverless architecture. This serverless architecture pattern is these days very popular because serverless architectures are reduce your operational complexity. We can use only their infrastructure. This is not a serverless means function as a service, because normally in traditional cloud services, they provide virtual machines, databases, storage services and all. But in this kind now they have some Azure functions, US Lambda functions, and Google Cloud Function kind of function as a service. So when you are designing a software, then you can use easily those Lambda function kind of things and run your code on a server, on cloud, without provisioning any VMs or any other infra level things you no need to think about, and purely you can focus on your application logic. And scalability is a fundamental feature of any cloud provider. So it's there anyway. They have very advanced scale automatic scaling mechanism. So no need to worry about scaling. And productivity also high, because you can easily, without provisioning any hardware or any other services, any other infra level things, you can easily deploy the service on as a cloud function. And other disadvantage of this kind of architecture is vendor lock-in. Vendor lock-in means if you deploy your service on one cloud vendor, example in US, then it's very difficult to migrate to another vendor or on-prem. Because if you are develop a system, design a system for one particular vendor, there are some APIs and services are unique to that particular cloud vendor. So it's difficult to migrate to one vendor to other vendors. So there is a vendor lock-in is there. That's why some vendors also encourage to do a multi-cloud serverless design. I capture this article from Microsoft site. They also mention if you are going to do serverless multi-cloud design, use two vendors, because then you can reduce the vendor lock-in disadvantage and you can route your traffic 50-50, or if you have more benefit from one vendor, then you can full traffic, and other site you can keep as a backup. And another thing is there are some limited controls, because most of the developers and architects like to go through some infra level and do some improvements. And so this but in the cloud environment, we don't have that control. So we don't have control to underlying infrastructure. Another thing is all this start latency. That means in this kind of architecture, in cloud function, if you are using cloud function, if this cloud function idle for some certain period, after that after idle period, if you send some event or send some message to that function, it takes some considerable time to respond back. We call that one is called start latency, but it's continuously running its response back. But if your function is idle, And the first, after idle, the first request getting some latency. If you are running very sensitive application, then it will be a problem. So you need to think about send some dummy request or whatever the things, that mechanism you have to think about if you are using, if you want to avoid that kind of cold state start latency. Another thing is execution limits. In the current, in the today, we the some cloud vendors say there is some limitation to execution time, because they provide these function for some only some in the millisecond kind of second level executions, but you cannot run continuously running more than 15 minutes. I think in the AWS they provide 15 minutes execution time. More than you, if you have some application requirement to process something more than 15 seconds, then you cannot use this one, because there are some limitation. I don't know, they will increase or optimize those things later, but in the these days there are some each. I'm not remember Azure and Google, but yes, they have some 15-minute limitation for execute the cloud functions. Okay, so those are the areas, those are the architecture patterns I discussed today. So what do you think? What is the best architecture patterns? You have any thoughts about what is best? And these are some areas. I'm not going to each and every things. These are the areas we discuss. But my conclusion here is there are no any best architecture patterns. We need to select and blend architectures and give some proper output to user. And there, each architecture patterns has some strong area as well as some weak areas. Then we need to properly select each architecture pattern, and we can blend and provide design our platform. Okay, I have some articles related to this software architecture patterns. In this is from Amazon. Amazon website is initially they build their website is a kind of a large monolithic design. They said it's a very big code and very big monolithic. And after that, I think you can now you have idea with this session. If you refer this session, what is the challenges they face? Maybe they have some scalability issue. Then they move to monolithic to distributed architecture. There are many monolithic to modern architecture, but there are many examples are there, many articles are there, but there are some other way around also there. This is also Amazon example. Amazon Prime, Amazon Prime is a streaming service, same as Netflix. So Amazon Prime, they initially used the microservice and serverless approach to build their monitoring system. Actually, Prime monitoring system, Prime, that platform monitoring system, not their core modules, but they initially used that kind of microservice serverless approach. But after that, they analyzed their system and their requirements and all. Then after they moved to monolithic design. You can see they reduce their cost by 90%. It's a huge amount. Then they think even they have more infrastructure, more technology, they use some EC2 virtual machines and run their applications to reduce their cost. No need to stay with the latest technology. And they get that back to monolithic and get that advantage. Okay, that's why I told I don't have a conclusion to this is the best and this is the latest. We can anyway blend all the architecture patterns and efficiently use to our platform. Okay, so if you have any questions.
If anyone has any questions, you can raise your hand and I'll enable your mic for you, or you can type it up in the chat.
Hi, Nirmal.
Hi, Darshi.
So I'm just wondering, I mean, it's a great presentation. Now, as a developer or architect, when they design their architecture for a product or applications using different patterns that you have explained, how do they make sure that they have chosen the right architecture pattern before actually, starting the development cycle? Is there any tools or validations that they can follow to make sure that they are on the right track?
No, I don't think we don't have that kind of tool actually. I think we need to think about the cost and the forecasted demand and those things, those that kind of fact we need to think. But I don't think we have proper tools and all to decide that one. Based on your application requirement and business requirement, business growth, we need to think about the architecture pattern.
Okay.
I add on top of that, guys. So yeah, as actually Nirmal said, there's no tool to validate it, but there are guidelines given to validate it, right? So
Yeah.
example, if it is AWS and Azure or GCP, every public cloud they have given a framework which is called well-architected framework, right? So your design you can actually go there in their website. For almost all the use cases in the world, they have given a reference architecture and which is optimized way. And you can refer to it and you can optimize your own architectures, as well as if it is particular public cloud, if you are a partner, you can actually you can request them to the partner manager, then their architects will come and actually validate it, whether our architecture actually has followed the best practices and whether it has been optimized and things like that. And so that is that. And one other thing I wanted to add on top of what Dr. Nirmal said is that serverless architecture also saves actually monthly cloud costs, because you only pay for the time that cloud function or
Execution
whatever
time.
serverless service is run. Yeah, so it is actually not like taking a VM and running a service. In that sense, you are paying for the whole year. You are paying for that VM, but serverless, it is actually charged only for the actually time that you are consuming the service. So if it is a cloud function, you are charged for the time that the cloud function has run, right? So there's a significant saving on that in that sense.
Yeah.
Thanks.
Yes, that's why in my slide also I get from Microsoft site, but they mention this also because that is the best architecture patterns, because that's why they are not stick to their one, but they always provide correct and proper architecture pattern we can use. So to answer your question, we need to validate. There are tools actually.
Thank you, Nirmal. It was a really engaging session and it was a lot of information to process also. Thanks to all our participants for staying until the very end and asking engaging questions. Please join us for the next TechTonic session in November. Thanks, everyone. Have a good day.